In this short little video, I will review the concept of the partial derivative. With partial derivatives, we have some function z, which has two right-hand side variables, in this case x and y. The partial derivative of z with respect to x measures the rate of change of z with respect to x while y is held constant. And the partial derivative of z with respect to y measures the rate of change of z with respect to y while x is held constant. So it sounds a little bit confusing at first, but hopefully it won't be too bad. Several ways of denoting a derivative might be something like this. These are like little d's with the squirrely top on them. So this is a partial derivative of z with respect to x. Also another way of writing that could be such as like this, z subscript x, or perhaps f subscript x. And we got the partial derivative of z with respect to y. Likewise, different ways of noting what we're doing. Okay, so let's get a new clean sheet here. So the best way to see what partial derivatives are all about is let's do some examples. Let's say that z just equals a constant. So the partial derivative of z with respect to x will be 0, and the partial derivative of z with respect to y will equal 0. Okay, so not too bad. So if z equals, let's say 5, partial derivative of z with respect to x is 0, partial derivative of z with respect to y equals 0. Let's say that z equals now, let's say 6x. Partial derivative of z with respect to x equals 6. Partial derivative of z with respect to y equals 0. Let's say that z equals xy squared. Partial derivative of z with respect to x here is going to equal y squared. We're treating y as a constant, so we got some constant here, y squared multiplied by x. The derivative of x is just 1, so we get back y squared. Partial derivative of z with respect to y equals 2xy. I basically performed the power function rule on y squared. The derivative of y squared is 2y. That 2y is touching x, so we bring back the x and we get 2xy. Let's do some other examples. Let's say that z equals 5x plus 12y. Partial derivative of this with respect to x is just 5. Here, this result of 12 times y is just treated as a big constant, and a derivative of a constant is 0. That falls away. And likewise, a partial derivative of z with respect to y is just going to be 12. Some other examples. Let's say that z equals x squared times y cubed. Partial derivative of z with respect to x. We take the derivative of x squared, we get 2x, but since x is touching a constant, we're just going to bring that constant along for the ride. Partial derivative of z with respect to y. You're going to concentrate on taking the derivative of y to the power of 3, which is going to be 3y squared. Okay. The x is hanging around for the ride. It's just a constant. So you'll get the result of 3x squared y squared. Let's do another example. X to the 1/2 power multiplied by y squared. Partial derivative of z with respect to x. Okay, we're going to bring down that 1/2 from the x. Got to subtract 1 from the 1/2. And y squared is hanging around for the ride, just treat it as a constant. And then partial z with respect to y. We're going to get the following result. Derivative of y squared is just 2y, and the square root of x is just hanging around for the ride, and we get the following result.